We're going to do simultaneous equations. I'm just going to recap some of the issues that we had previously with simultaneous equations, and possibly introduce a new concept if you haven't seen it before. But it's quite a simple thing to sort of just get through in our minds. What do we do when we have, let's say we're given something, right? Previously, what we had is we had this. Let me just get my pen onto that. They gave us 2x minus y equals to 10. And they gave us, say, 3x plus 2y equal to minus 6, let's say. So what did we do? That's a 10 there. All right, let me just correct that, make it look better as a 10. Okay, what did we do previously? We said you are equation number 1 and you are equation number 2. Then we decided if we were asked with elimination or if we were asked with regard to substitution, we'd take one of the two methods and we would do it from there. So what I'm going to do is I'm just going to use the elimination. We're going to use substitution later on as well. So let's have a look at elimination. Let us pick one. All right, let's say we say decide to eliminate, let's say y. Okay, it wouldn't have mattered if we wanted to choose x, but we choose y. Why? Because all we have to do is multiply equation 1 times 2 to get 2x minus 2y equal to 20. Okay. Then what do? We call that equation number 3. Then we slide equation number 2 in and we say you are 3x plus 2y equal to minus 6. This was equation 2. Draw a line. And now what do? We look at these two that we want to eliminate and we're going to say all I have to do is add them. All right. All we're going to have to do is add times 2. Sorry, that's a 4. My bad. That's a 4. Sorry, guys, I'm not even paying attention here. That's a 4x because I'm multiplying this by 2, right? Over there. Okay. So we've got 4x minus 2y equal 20. So we add them. So equations, we're going to take equation 3 and add equation 2. And we get 7x gone is equal to 14. Therefore, x equal to 2. Therefore, what do? We back substitute. And how do we back subs? We say, all right, pick any one. It doesn't matter. I'm going to say 2 times 2 minus y equals 10. And then basically, I've got 4 minus y equals 10. Minus y equals 10 minus 4, which is 6. Therefore, y is going to be equal to minus 6. Now, let's just stop at that point and look. We have got an x equal to 2 and a y equal to minus 6. That's actually two coordinates with the values 2 and minus 6, isn't it? All right. So essentially what are we doing here is we're putting these two equal to each other, aren't we? We're actually finding a point of intersection. We're going to come back to this now. Point of intersection. All right? I'll go through that in a seckie. Let's have a look at a slightly more complicated one. What if they give us this one? These are all examples. All right. If we've got x times y equals 100 and the other one they give us is 2x plus y equals 100. Okay. What do we do now? Well, what we do now is we've got a problem. We cannot here use the elimination, right? It's not going to work because we're going to be, remember, elimination is either you plus or you subtract. It's not going to work in this case. So with these, we are basically locked into a substitution, right? Now, you can either decide to substitute for x or for y. What do? Is we say, rearrange this. Y is equal to 100 minus 2x. Okay. Please note, try to avoid creating a fraction. I could have said x, so I'd have 2x is equal to 100 minus y. Therefore, x is going to be equal to 50 minus y over 2. There's the fraction that we want to avoid. All right? Why? Because it's just easier. Why would we want to have fractions? Nobody likes them. So let's just leave them out of the equation, shall we? So we say, all right, now we've got this, right? We've rearranged and gotten y is equal to 100 minus 2x. What is the next step? The next step is in substitution. We say x times, and I replace that y by 100 minus 2x is equal to 100. Multiply out. 100x minus 2x squared is equal to 100. Okay, what does that look like? That looks like a quadratic, doesn't it? Right, it is. We just rearrange it to look nice in the correct form. 100x minus 100 is equal to 0. Okay, and I see that what I did is I said, okay, I have well, let's just carry on with it. It doesn't matter. All right, and let's divide through by minus 2. So you get x squared minus 50x plus 100 is equal to 0. And you will solve for x, okay? In my notes here, I changed it to a 200 at some stage, I see. Never mind. The point is, you would solve for x, right? And we're going to get an x value, okay? I hope this one gives me an x value. Let me just have a look. 5, 3, 1 equals minus 50 equals 100 equals, okay. Yeah, it does. It gives me 47.9. Not nice values. And the next one is going to be 2.08. Okay, but illustrative, what have I got? I've got two x values. Okay, so I have to substitute to get two y values, correct? I'm going to get, if I substitute in here, let's see, what do we get? We say, therefore, I can say x times y equals 100, so 47.9 times, 47.9 times 2 plus y must equal 100. Therefore, y is going to be equal to 2 times 47.2. Just get this back to normal. 47.9 times 2 is equal to that, minus 100 is going to be equal to minus 4.2. And the other one, we put in the 2.08, and I can always say that y is also equal to 100 divided by 2.08, depending on which way you want to go. 100 divide 2.08 is going to be equal to 48.07. All right. So what are we getting? You can see they're very close to each other. All right. We're getting coordinates of x, y, and another x2 and y2. Okay. x1, y1, and x2, y2. Right. So what we got there is we're saying, right, what have we got here, right? What have we got? We say, okay, what does it mean when we solve the simultaneous equations? Let's look. Okay, we get another page going here. What does it mean? Remember, let's say we've got x plus y equals 1 and x minus y equals 2. Okay, what does it mean? Look, if you rearrange this, y is equal to 1 minus x, and over here, all right, y is equal to x minus 2. So f of x is going to be equal to 1 minus x, and g of x is going to be x minus 2. So there's two straight lines. Correct? Two straight lines. What is it actually giving when we solve those simultaneously? What are we actually doing? We are putting f of x equal to g of x, and we are finding point of intersection. Okay? Therefore, on the previous one, we had what? Well, we had let's just go back up and have a look at the two lines. Well, we had a straight line, 2x plus y equals 100. Let's write it down. 2x plus y equals 100. We had 2x plus y equals 100. And we also have xy equals 100. What are these? Well, xy is equal to 100 is this graph, isn't it? Oops, that's very awful. Okay, this is a hyperbola. And this is y is equal to a straight line, isn't it? So we've got a straight line and it's going through there, okay, and it's a minus, so it's going to be coming down at a negative, and I think that are the 2 points that we've picked up there, right? Remember, we could have had a graph going the opposite way like that, whereas we would also have picked up 2 points. What if we actually get, say for example, when we're doing this, we don't get an answer. We get the square root of a negative number. It means they don't intersect, because we could have put a line through here, couldn't we? Therefore, it doesn't intersect. So if you don't necessarily get points of intersection, it doesn't mean they intersect. Okay? So watch out in the question what they're going to ask. If in the question they say, do the graphs intersect? Then they may not. Okay? If they say, find the points of intersection A and B, then obviously they do. Okay? So that if you don't get an answer, then there would have been an error somewhere there. Let's have a look at another example of this. This is quite a cool one. All right, let me just put myself back to that. They give us let's just put down an example here. Okay, x squared plus y squared equals 4. Now, I do wish my writing was better. Equals 4. And they say xy equals 1. Whoa, this is quite a hairy one, isn't it? Because what have we got here? In essence, the x squared plus y squared is a circle with radius 2. So this is basically the graph of the x squared plus y squared is going to be a circle with r equal to 2. Okay, so it's going to be 2 minus 2, 2 minus 2. Okay. The next is we've got xy equals 1. What is that? That's a hyperbola, isn't it? So let's put him in. So he's going to come down here like this and come down there like that, correct? So we are going to get 4 points of intersection. Now, it doesn't matter. I'm not saying you need to know and how to draw these. Just conceptually, you can see there that there's 4. How would we do this? Would you mess around with something required? Look at the messiness. Let's say we say, okay, x is equal to 4 minus y squared over square root of that. Right? Now to go and substitute that into there makes a mess. The easiest way is to rearrange this one, and what I did is I said y is equal to 1 over x. Right? Now we go back and we substitute. X squared plus, I'm going to remove that one. Now it's supposed to be y squared, so I'm replacing it with 1 over x. Okay? Just show you this is going in there, right? I am replacing the y squared with the 1 over x all squared. Okay? Let's equal to 4. Let's multiply out the bracket. X squared plus 1 squared over x squared is equal to 4. Oh my goodness. Multiply. Remember the rule of fractions? multiply through by the LCD. We're going to get x to the fourth plus 1 equals 4x squared, are we not? Right. Now we've got to solve this. How do we do it? Well, you've got a choice. Let's look at it. This looks like x to the fourth minus 4x squared plus 1 equals 0. It looks reminiscent of a quadratic, doesn't it? K method. Let k equal x squared. Right? Therefore, k squared is x to the fourth. So I've got k squared minus 4k plus 1 equals 0. And we solve that. Okay? Now, I didn't say it was going to be pretty, and it's not. K in this case comes out to be equal to, all right, 3.732. Or k equals 0.267. Okay, I just used the calculator to work that out for me. 0.267. I used the calculator to work it out. You'd have used the formula or used the calculator to do so. Where are we now? Well, we're now there. What do we have to do with the k method? We put it back. K is x squared. Therefore, x squared is equal to 3.732 and x squared is equal to 0.267. Now we have to find x. X is going to be equal to plus or minus the square root of 3.732. X is plus or minus the square root of 0.267. What am I going to do next? Create a new page. Now I've got, therefore, x is going to be plus minus 1.94, or x is going to be plus or minus 0.52. Okay. We have got 4 x's. We've got x equal to plus 1.94, x equal to minus 1.94, x equal to plus 0.52, and x equals minus 0.52. Okay. In other words, we've got x 1, 2, 3, and 4. Right, 1, 2, 3, and 4. Just put that nice neater. 1, 2, 3, and 4. So therefore, we are going to get 4 y values. So therefore, we get the y here, okay, is 1 over plus 1.94. Let me just. Y is going to be 1 over minus 1.94. Here, y is going to be 1 over 0.52. Y is equal to 1 over minus 0.52. What do we end up with? We end up with 0.52 minus 0.52. Okay. Over here, 1.94 and minus 1.94. So with my coordinates are, this is what they are. 1.94 and 0.52, right? Minus 1.94 and minus 0.52. And on the other side, 0.52, 1.94, and minus 0.52, and minus 1.94. There are 4 points of intersection. Let's go back to our graph. I drew it here very roughly. Can you see? 4 points of intersection. Let's put them in red. There's one, there's one, there's one, and there's one. 1, 2, 3, and 4. Those don't tie up, by the way, to the other numbers of 1, 2, 3, and 4. But I'm trying to give you a mental picture here that where these numbers are is they're showing us points of intersection on a graph. So we're going to get 4 of these, are we not? Now, let's just continue a little bit with this, all right? what happens? Okay, what have I got here? I've got, let's have a look at x plus y. Okay, let's have a look at x plus y equal to 1. Because they've now said, given x plus y equals 1 and x minus y equals 2, x minus y equals 2, sorry. Okay. Find the points of intersection. Well, what would you do? You would change this to y is equal to 1 minus x, and we would say, on this case here, y is equal to x minus 2. And we would put them equal, wouldn't we? 1 minus x is equal to x minus 2. And you'd then solve that 1 minus 2x minus 2. And eventually we're going to get x equal to 3 over 2. And then back substitute for y, right? So it's going to give us the same answers as solving simultaneously. Because if we solved x plus y equal to 1 and x minus y equal to 2, we would basically just say, therefore, okay, 2x is equal to 3, x is equal to 3 over 2, and back substitute again, right? It's the same thing. It's giving us the points of intersection, right? Now, what I'm going to do is I'm going to stop this one because I've now got two quite long ones that I want to go through, and I don't want to be pushed for time in them. So I'm going to stop this one and then carry on with the next in the next session. Cheers. See you in the next session where we're going to, please make sure you've got pen and paper and stop, go through the steps, write down your own recipe on the side, right? That's the key to this, and go through it with me, all right? Cheers. See you next time. Bye.